It feels like you blink and there's another major AI development, doesn't it? The pace is just incredible.
It really is. We're seeing shifts everywhere, globally, from the basic building blocks right up to, well, completely new applications.
Yeah, it's a lot to track.
Absolutely. And that's, why we do this. Welcome to the deep dive. We try to zero in on the really significant AI news, cut through the hype, and give you the core understanding.
Think of it as your quick briefing on what's actually making waves.
Exactly. What you really need to know.
And today, we've got some fascinating updates lined up. We're looking at hardware, the evolution of the AI models themselves, and some really interesting real-world uses popping up.
So our mission today is pretty straightforward. Pull out the key insights from these latest moves. What's the potential impact? Let's get into it.
Okay, first up, Nvidia. Big news from them. They've launched something called DGX Cloud Lepton.
Right. This aims squarely at a problem anyone in AI development knows well, actually getting access to enough high-performance GPU computing power. Demand is just off the charts.
It's been a massive bottleneck, hasn't it?
Huge. So DGX Cloud Lepton is NVIDIA's answer.
So how does it work, practically speaking? Is it like an exchange?
That's a good way to think about it. It's basically a global marketplace connecting developers who need that GPU power with available capacity from different cloud providers. Companies like CoreWeave, Foxconn, SoftBank are involved.
Okay, so it's bridging that gap.
Precisely. It could be a game changer for startups or even bigger companies struggling to get the hardware they need. It's sort of democratizing access.
And it sounds flexible, too. Like you can use it for short projects or longer-term stuff.
Yeah, they're supporting both on-demand use and longer reservations. And crucially, they're highlighting regional availability.
Right, for data sovereignty laws and keeping latency down.
Exactly. You need to compute close sometimes. Jensen Huang calls it a planetary-scale AI factory vision.
Wow, that's ambitious.
It is. It connects this huge distributed network of GPUs. And, it could really cement NVIDIA's position even further if they pull this off effectively.
Yeah. So the practical side. Managing workloads across different clouds sounds like a headache. How do they handle that?
Well, that's where the integration comes in.
Yeah.
DGX Cloud Lepton ties into NVIDIA's existing software stack, all those tools for training models, testing, deployment.
Ah, okay. So it smooths out the workflow.
That's the goal. And for the cloud providers offering the GPUs, it includes things like real-time diagnostics and automated troubleshooting.
So potentially less downtime for them.
Right, and less operational hassle.
They also mentioned something called exemplar clouds. What's that about?
Think of it as a kind of quality standard. It's a framework using NVIDIA's tools and best practices to help their cloud partners offer better, more secure AI services.
So ensuring a certain level of performance.
Exactly. And interestingly, Yada Data Services in Asia-Pacific is the first one announced for this program. Shows the global interest.
Right, so it's early days, early access now, but expected to roll out more broadly.
Yeah. This could really change how accessible high-end AI compute is.
Definitely lowers the barrier to entry.
It does. Though you wonder how smaller cloud players will compete in this kind of marketplace.
Good point. Okay, let's pivot now. From the hardware to the models themselves, OpenAI and GPT-5.
Right. So the main message around GPT-5 seems to be, well, not necessarily a completely radical new thing, but making what they have better and with less model switching.
Less model switching, so more seamless.
Exactly. They want tighter integration between their tools. Things like Codex for Code, Deep Research, this thing called Operator, their memory system. The idea is for it all to work together more smoothly.
So you as the user don't have to consciously pick the right tool for the job quite so much.
That seems to be the direction, a more unified, context-aware AI environment, which, could really change how we interact with these systems day to day.
An operator, that's the screen agent, right? Any updates there?
Still in research, apparently, but they're hinting an update is coming soon that can make it very useful. Right now, it can do basic stuff like control your browser.
An AI that can actually use your computer alongside you. That's
Yeah.
interesting.
The potential there is huge, right?
Yeah.
Automating tasks, navigating apps, a proper digital assistant.
Now, didn't they initially talk about merging GPT models with their own models for GPT-5?
They did, but it sounds like that turned out to be harder than expected. Sam Altman kind of walked back some of that early talk, and they ended up releasing O3 and O4 Mini as separate specialized reasoning models instead.
Which is still progress, just different progress.
Exactly. It shows how complex this R&D really is. Things don't always go to plan A.
Jerry Torek from OpenAI also had some interesting thoughts on tokens. the demand for them.
Yeah. Tokens being the basic Unix AI models process, he basically said demand isn't slowing down.
Why not?
His point is the trade-off between how useful the AI is and how much it costs is getting better all the time. So even if models don't improve drastically, just making more tokens available cheaper adds a lot of value.
So scaling up the infrastructure is valuable in itself.
That's his argument. Sheer
Yeah.
computational scale still matters a lot.
And he also talked about jobs, right? AI taking over.
Yeah, he offered a slightly more optimistic take, maybe. He thinks there will always be human roles, and maybe the last job could even be supervising AIs.
Supervising the AI, huh?
It's a different vision of the future workforce.
Yeah.
More collaboration, less outright replacement, perhaps.
He also seemed a bit dismissive of traditional benchmarks for comparing models like GPT, Claude, Gemini.
Yeah, he leans much more towards real-world task performance. How well does it actually do things people need done?
Which makes sense, ultimately.
Right, the benchmarks don't always capture true utility. And he mentioned OpenAI's long-term goal is for the system to just pick the best model for your task automatically. You wouldn't even need to know.
Making it invisible, more user-friendly.
That's the idea. Less focus on the tech, more on what it can do for you.
Yeah, okay. Now, let's shift focus pretty dramatically. Geographically, too. China, this three-body computing constellation. Satellites doing AI in space.
Yeah, this is genuinely groundbreaking stuff.
Yeah.
Back on May 14th, they launched 12 satellites on a Long March rocket. But these aren't just any satellites. They formed this constellation by a commercial company, ADA Space.
Yeah.
And the key innovation, they process data directly in space.
Whoa, so less beaming raw data back down to Earth.
Exactly. That's a major leap. These things have serious onboard computing power. 5 petiops combined, 30 terabytes of storage.
Wow, that's a lot for space.
It is. Plus advanced AI, high-speed laser links between the satellites like 100 DBPs and remote sensing gear. But processing data up there is the big change. Faster insights for time-critical stuff.
And it's not just looking at Earth, right? There's something about space science, too.
Right. One carries an X-ray instrument for detecting things like gamma-ray bursts, so it's multi-purpose.
And ADA Space is calling it the world's first dedicated orbital computing constellation.
That's their claim. It marks a shift, satellites becoming orbiting data centers and AI platforms, not just sensors or relays.
And this is just the start, part of a bigger plan?
Apparently so. It's part of the larger Star Compute program, a collaboration with Zhejiang Lab. The ultimate aim, a network of 2,800 satellites.
2,800.
Yeah. It's incredibly ambitious. The goal is clearly to meet demand for real-time space computing and position China as a leader in this whole new area.
The implications seem huge. Space-based cloud computing, strategic competition, military uses.
All of the above, potentially. While the US and Europe have done edge computing tests in space, nothing on this scale, designed from the ground up as an AI constellation. It's a major strategic bet.
And ADI Space, the company, they're relatively new.
Founded 2018, focused on AI satellite tech, already filed for an IPO. Zhejiang Lab is a major research institute backed by the government, a university, and Alibaba, focused on AI, big data.
So serious players involved.
Definitely. And there are other partners, too, for ground systems and AI platforms. It all seems tied into China's big new infrastructures push and their goal of leading in AI by 2030, with space as a key part of that.
And this was just one launch of many for China this year.
Yeah, their 26th orbital attempt already. They're moving fast in space.
It really paints a picture of integrating AI right into the space infrastructure itself.
Absolutely. Opens up completely new ways to use orbit.
Okay, let's bring it back down to Earth for our last piece. A really practical application, AI in healthcare. Sini AI running a trial clinic in Saudi Arabia.
Yeah, this is fascinating. They partnered with Al Musa Health Group in the Al Asa region. And the core of the clinic is their AI, called Dr. Hua, doing the primary diagnosis.
How does that actually work for the patient?
Well, the patient reports symptoms using a tablet. Then human assistants get other data, ECGs, X-rays, that kind of thing. Dr. Hua analyzes it all and suggests a treatment plan.
Suggests.
Right? That plan is then reviewed and approved by a human doctor. Importantly, that human doctor doesn't see the patient initially.
So there's a human check, but the AI does the main diagnostic workup.
Exactly. With human doctors on hand for emergencies and oversight, of course, it's not fully autonomous decision-making.
And Saudi Arabia, interesting place for this trial.
It seems the Middle East is becoming a bit of a hotbed for testing advanced healthcare AI. Saudi Arabia is investing heavily, over $50 billion into digital health.
That's serious money. Creates a welcoming environment.
For sure. And Sini isn't alone. Other Chinese health tech firms are expanding there too. The whole region's healthcare spending is projected to grow massively, and AI is seen as a big potential economic booster. They're building the infrastructure too, like large health data exchanges.
But what about the rules? Regulations for AI in medicine must be tricky.
Globally, yeah, they're still playing catch up. Sydney's approach reflects that they're running this as a free trial while they wait for formal regulatory approval. They've set an 18-month timeline for that.
So test the tech while the rules get figured out.
Kind of. Authorities everywhere are focused on robust governance, making sure AI used for diagnosis and treatment is safe and effective. It's a complex balance.
And you also have to get doctors on board, right? There must be some skepticism.
Oh, absolutely. That's a huge factor.
Hmm.
Research shows doctors need to feel they're in control, they need training, they need transparency about how the AI works.
Physician hesitancy, yeah.
Exactly. The American Hospital Association points it out as a barrier. So Cindy's model, with that human doctor review step, that directly addresses some of that skepticism. It keeps a human in the loop.
Makes sense. What about patients?
Patient acceptance is key too, of course. Public awareness and education will be important as these tools become more common. Cindy is also starting relatively small, focusing initially on just 30 respiratory conditions.
A gradual approach to build trust.
Seems like it. Demonstrate value in a specific area first.
So looking back at everything we've covered, there are some clear threads connecting these stories, aren't there?
Definitely. We're seeing this push for more raw computational power, like with Nvidia. Then there's the drive to make the AI models themselves more capable and integrated, like OpenAI's focus.
And then AI expanding into totally new areas, literally into space with China's constellation, and deep into sensitive sectors like healthcare with the Sydney trial.
Exactly. NVIDIA's marketplace could really open up access to AI development.
Hmm.
OpenAI is aiming for systems that are just easier and smarter to use. China's move into space computing is, well, it's a bold new frontier.
And the Sydney Clinic shows AI getting real, tackling complex problems, but also bumping up against those crucial questions of regulation, trust, and adoption.
It all points to AI becoming not just more powerful, but more pervasive, more accessible, woven much more deeply into everything.
So the takeaway for you listening is really this. AI isn't slowing down. The innovation is happening on all fronts, hardware, software, applications. It's worth keeping a close eye on these trends because they're shaping the future, likely faster than we think. Which of these developments do you think holds the most potential or maybe raises the biggest questions for how we adapt? Something to ponder.